Hi, welcome to our 9th training session, where we will demonstrate how to use pulse width modulation technique to create musical scales and simple songs and play it on a speaker. Any embedded system project involves 3 important steps. The first step, we select embedded C as our programming language. The second step, LPC2148 based evaluation board and simple toy speaker to play music. Pulse width modulation, or PWM, is a popular method for simulating analog signals using digital outputs. Programs written in C are readable and easy to debug. To debug embedded C program on the PC, we use a simulator. We use a Jaguar debugger to download and test the program running on the target hardware. All our C programs starts from main. In music theory, a note is a sound wave, which has a unique name, with a unique fundamental frequency. Each musical note is played for a certain duration of time. In our first function call, we configure only one pin, P0.7, for pulse width modulation. This pin will be used for generating musical notes to be played on a speaker. In the second function call, we initialize timer 0 and generate timer interrupt every 1 millisecond. We use timer to time how much time each music note should play. This note duration depends on how fast or how slow the music is being played. In the third function call, we initialize the PWM block. We use the PWM block to generate various musical notes of varying frequency on pin P0.7. We then enter an unending loop, wherein we play music, which is combination of multiple notes of varying duration. It is important in music that notes are played in time and rhythm. A 16 MHz external crystal drives the LPC2148 processor. The peripheral clock, during power-up, defaults to 4 MHz. In the first function call, we configure P0.7 pin for alternate function of PWM2. The wizard is used to generate the configuration code, which computes the values for pin select 0. In the second function call, we initializes the timer for generating 1 millisecond interrupt. We generate a 1 millisecond interrupt by programming the match register MR0. The crossware wizard computes the count values to be loaded into the MR0 register and generates the code for resetting the timer counter and also generating timer interrupt. The vector interrupt controller is programmed with slot 0 for timer 0 interrupt and the vector address pointing to timer interrupt subroutine. Every 1 millisecond, the timer interrupt subroutine will be called. Here we decrement the note duration counter. If we set a note time for 100 millisecond, then the note duration count value will be decremented here. We enable timer for generating the next 1 microsecond interrupt by clearing the match 0 interrupt bit set in the IR register. Similarly, we signal the VIC end of timer routine by a dummy write to the vector address register. Every musical note has a fundamental frequency. Note SA has a fundamental frequency of 240 Hz. This means the music signal will oscillate 240 times per second. If 240 oscillations takes 1 second, then one oscillation of the note defines the period of the note. A musical note is a sinusoidal waveform, and we are going to generate a square waveform having the same musical note frequency. To generate this note on pin P0.7, using PWM block, we are going to use 2 registers MR0 and MR1. MR0 defines the period, while MR1 defines the on time. When on time is equal to of time, we have a 50% duty cycle, and the square wave approximates a sinusoidal note waveform. We will be using the wizard to code the PWM block. The first step is to define the note period. The MR0 count value defines the note period. We have 5 registers, MR1 through 5, to define the on time. We use MR2, which drives the output P0.7. MR2 value defines the note duty cycle and the note signal volume. A melody is a sequence of notes, and each note is played for a certain duration of time. Hence the note period is going to change dynamically as music note changes, and to do this, we will need to change MR0 value for each new note. This dynamic transition requires the MR0 register to be updated automatically, and this happens by writing a 1 bit in the latch register. A melody is a collection of musical tones that are grouped together as a single entity. Most compositions consist of multiple melodies, rock band, guitarist, vocalist, all working in conjunction with one another. The melody in a piece of music consists of 2 primary components. The first component, the melody array, is the pitch or the tone frequency produced by multiple instruments. These pitches are arranged as a series of notes, with note names one after another. The second component is the note duration, or the tempo array. These note durations are for each individual notes, defined in the melody array. The last function call, sing melody, we use both the array, the melody array, and the tempo array. The for loop initializes the PWM block to load the first music note, and computes the note period, and loads it into the MR0 register. Then it also loads the note duration, which the timer block uses to play the music note for the note duration time. The for loop continues till it plays the whole music composition. Between each note, we play a silence to distinguish between each note.